Now, you guys have a mechanism for doing important things first. You sit down every evening and say, what should I work on? Okay, how do you make that decision? Do you just randomly pick any one of the 700 assignments between now and the end of the term? Say, yeah, that's the next one. You know, sorry, 6004, you didn't do you last night because I got doing something else. What do you do?
First you, first serve.
Well, what you do is you try, I mean, you might have different strategies, but you're certainly looking to prioritize, right, and pick things where the deadlines are soon. Those are always a good thing to work on. And in fact, there's a sort of a strategy called earliest deadline, which is, maybe you should work on that first. Okay. Now, that's not so good if you're also controlling the nuclear reactor, right? I mean, in some sense, you need to be able to drop what you're doing and say, okay, I have a new deadline, 4 milliseconds. And so this earliest deadline thing is a good idea, but there has to be a notion of perhaps interrupting something you've already started doing. So we'll get to there. So our first step is a so-called weak priority system. And the weak priority system is pretty straightforward. What we're going to do is organize things so whenever we're making a choice of what to run, which is at the end of each interrupt handler, we're about ready to either return to user mode or deal with another interrupt, when we have a choice about what, we never stop running what we're doing, but if we have at least at the kernel level, but if we have a choice of what to do, we're going to go off and do the disk first. So we're trying to, this notion of assigning a priority. So the weak system, interrupt system, basically given a choice of interrupts all arriving in short order, not instantaneously the same, but very quickly one after another, printer, keyboard, and disk. Once we get started on the printer, we're not going to stop doing that, but if there's a disk interrupt to be handled, it'll happen before the keyboard interrupt gets handled. In other words, the disk has a higher priority. So rather than just accepting an arbitrary ordering of what to do next, we're going to refer to the priorities. We're going to look at the priorities of everything that needs doing. And what we do, we'll pick the one with the highest priority. So if at the end of the current task, if there's ever a disk thing to be done, we do it. And if there's no disk thing to be done, if there's a printer thing to be done, we do it, and so forth and so on. Everybody sort of understand what's weak about it? It's weak because we're not making any changes. We're not stopping what we're doing now, but the next time we choose something to do, we'll use the priority system to tell us what to do. Yes?
If we're always doing disk things, then how can the disk be delayed at all?
The disk can be delayed because in this system, we will not stop what we're doing. So if we started a printer service, we simply won't start the disk thing until the printer is done.
But why would you have started the printer?
Oh, so the scenario here, as I said, these didn't actually arrive at quite the same time. So what happened is we got an interrupt from the printer, and we started doing that. But very shortly afterwards, you got a disk and a keyboard interrupt. So we're not going to actually interrupt the printer routine. But when we get to the end of the printer routine, we're going to choose the highest priority thing to do. And under these assumptions, we can calculate new latencies, where what we have to do is to wait in the case of the disk, we have to wait for the longest service time of somebody who might have been running, which in this case is the keyboard. For the keyboard and the printer, we not only have to wait for the longest thing that might have been running, that's not us, plus anything that's higher priority that might get in our way. Okay, so that's sort of the numbers you see here. And this is an improvement over the previous slide. The disk now isn't waiting so long. Right, the disk doesn't have to wait arbitrarily for the keyboard to get out of the way and the printer to get out of the way. It has to wait for the worst case time of something that was running, but then it will be next in line. So the weak system sort of gets us a start down the path of what we want to do. And you can see that the latencies have improved now. It's only delayed by the slowest of all the services, which in this case is the keyboard.